To simplify this, 4 over root 2 minus 7, we need to make it so that there is not a radical in the denominator, right? Because the radical that's there, root 2, is simplified. If you just look at root 2, there's no perfect square factor. The problem is that it's in the denominator and we can't have a radical in the denominator. And so we need to multiply by something to get rid of that. And some of you figured it out. So one of you that figured it out can tell us what you have to multiply by. The what?
Conjugate of the
The conjugate of the denominator, right. And so the denominator is root 2 minus 7. We need to multiply by root 2 plus 7. Why? Because if you look back to that sheet we did with conjugates, you'll see that when we multiplied a radical binomial by its conjugate, we got an integer. And that's what we want. So this is going to be multiplied by, on the bottom, root 2, plus 7. That's the conjugate of the denominator that's there. What do I have to multiply by on the top? Same thing. Why? Because it equals 1, right. Now we're multiplying by a fraction that's equal to 1, which is okay, because then the value is still the same. We'll do 4 times root 2. So numerator by numerator. That's 4 root 2. And then 4 times 7, so it's plus 28. And then the denominator, we're going to do root 2 times root 2, which is 2. And then root 2 times 7, which is 7 root 2. And then negative 7 times root 2, which is negative 7 root 2. And then negative 7 times 7, negative 49. And what you'll see always happens when you multiply these conjugate binomials is that the middle two terms cancel out. So we don't have any radicals left in the denominator, which is what the goal was. It was to simplify. And to be simplified, you can't have those radicals in the denominator. So the numerator here is 4 root 2 plus 28. And the denominator is 2 minus 49. So negative 47. I'm just trying to think if that can be simplified at all. One thing that you may want to do, and you don't have to do this, but it's sometimes strange to have a negative in the denominator. So you can move that negative to the numerator, and we could change this to negative 4 root 2 minus 28 over 7. Oh, sorry, over 47. So all I did was take the negative from the denominator and move it into the numerator. So really I like multiplied by 1 again. I multiplied by negative 1 over negative 1, which is just equal to 1. So that's another time when you do that, multiplying by 1.
I was going to say, like, what if like both numbers were negative?
Then you do the same thing and everything would change to positive, right?
Like everything?
Okay, let's try this one. 3 root 5 over root 6 plus 4. What are we going to multiply it by?
Root 6 minus 4.
Root 6 minus 4, right. Over root 6 minus 4. Multiply that out and we get, we're going to do 3 root 5 times root 6. So that's 3 root 30. And then 3 root 5 times negative 4. So negative 12 root 5. Remember, you're multiplying coefficients by coefficients, radicands by radicands. That's the numerator. The denominator, root 6 times root 6, which is 6, minus 4 root 6, plus 4 root 6, minus 16. That's 4 times negative 4. And again, this part cancels out. So we have 3 root 30 minus 12 root 5 over negative 10. So let's just simplify a little bit further by multiplying by -1 over -1, which changes that 10 on the bottom to a positive number. And the top we get -3 root 30 plus 12 root 5. The negatives change to positives and the positives change to negatives. And that looks like a pretty good answer there. Make sure you are checking to see if you can simplify further. Is there a perfect square factor in any of the radicands? And the answer here is no. So you can't do anything with that. Is there a common factor overall? And the answer is no. So that one's done. So I simplified this here by multiplying by 4 plus 5 root 5. And I end up with this at the end. You might notice that I switched around the order. I took that 25, that whole number term, and put it at the end. Just because that's kind of the way that we usually write it. It doesn't matter. You're not going to lose points for that, for not doing that. And I actually decided to leave the negative on the bottom here because it's just going to be so many negatives on the top otherwise that I thought this looked nicer. But whatever. If you switched it and made all the top negative and the bottom positive, that's good too.
Wait, how did you get 25 off the top?
25 was the 5 times 5 root 5. So 1 times 5 is 5, and then root times 5 times root 5 is 5. 5 times 5 is 25. Oh, here's the last one. 9 over 4 minus root x. What do I need to multiply this one by? 4 plus root x. 4 plus root x. So this is going to be 9 times 4. 9 times root x. And then on the bottom, 4 times 4 is 16. Plus 4 root x minus 4 root x, and then minus x. Is anybody deciding just to not bother writing down those middle terms?
Yeah.
Do you know why I write them every time?
You get it stuck in your head.
Yeah, so you get it stuck in your head that you actually have to do that when you're multiplying two binomials. You can't just multiply the first two terms and the last two terms. You need to multiply them all out. And in this case, they're going to cancel out, but they're not always going to cancel out, right? They're going to cancel out when they're conjugates. That's the only time that they cancel out. So that's why I'm writing them out every time. So this becomes 36 plus 9 root x over 16 minus x. It's not just an integer on the bottom anymore, right? But is it fully simplified?
No.
No, why not?
Because they have. I give up. They all have the. Doesn't count. Does that count?
If they all had a common factor, but they don't. This is fully simplified, I think. It's not an integer on the bottom, but that's okay. What we need on the bottom is to not have any radicals, and there aren't any radicals in the denominator.